morning students. Chapter 7 System of Particles and Rotational Motion. Now we will see some MCQs for preparation of competitive exam. Okay, see here. If the angular momentum of body is increased by 50%, its rotational kinetic energy is increased by A, B, C or D. Okay. You are given options 125%, 50%, 100% or 25%. Okay. See, if angular momentum of body is increased by 50%. So first of all, what is meaning of this? See, I am assuming let initial angular momentum. Let initial angular momentum L1 is equal to L. Then what is final angular momentum L2 is equal to, see, increased by 50%. It means initially it is L. Increased by 50% means 50% of L. You have to understand meaning of this equation. Okay. Initially it is L, as it is increased by 50%. Okay, so L plus 50% of L. So yes, is equal to, it is L plus 50% means it is 50 divided by 100. L 0 cut 5 divided by 10 0.5 and plus L. So is equal to, it is 1.5 L. Simple. So first of all, if you are given such a relation, how to write? Whatever it may be, yes, it is angular momentum. Yes, you are here given angular momentum. If you are given data of temperature, then similarly you have to write initial temperature, final temperature. If you are given increase, then you have to write plus. If you are given decrease, you have to write minus. Okay. So yes, it is meaning of this first statement. Now we have to find its rotational kinetic energy. So now you have to obtain one relation between angular momentum and rotational kinetic energy. Angular momentum and rotational kinetic energy. See how to obtain such relation. We know that rotational kinetic energy K is equal to, it is half I omega square. So K, I can write this K is equal to, K is equal to, it is half I square omega square upon I. It means multiply by I and divide by I. Yes or no? Yes it is. Yes it is. Now you know one relation, that is angular momentum L is equal to I omega. Angular momentum L is equal to I omega. So here I square omega square I can write. So K is equal to, it is L square upon 2pi. It is L square upon 2pi. Clear about this? Again, rotational kinetic energy K is equal to half I omega square. K is equal to multiply by I and divide by I into omega. You know that it is angular momentum. So I square omega square is L square divided by 2I. Now 2, that is constant. For a given body, only angular momentum is increased. Object is same. So its moment of inertia is also same. So I is constant. So here we can say K is proportional to L square. K is proportional to L square. Clear? Any doubt? Okay, here kinetic energy K is proportional to L square. Okay, so first of all, you have to obtain one relation between two given quantity, angular momentum and rotational kinetic energy. Now, yes, it's compulsory. Okay, it is just method. Okay, you have to take a ratio 2 by 1. Means like this: K2 by K1 is equal to, here it is L2 upon L1 whole square. Simple. K2 upon K1 is equal to L2 upon L1 whole square. So K2 is equal to L2 upon L1. L2 it is 1.5 L. 1.5 L divided by L1 it is L whole square. So L cut, L cut. What is square of 1.25? Yes, obviously it is 2.25. It is 2.25 and yes, here it is given K2 upon K1. So therefore I can write K2 is equal to 2.25 K1. Any doubt? Any doubt? Simple. Yes, it is simple. Yes, it is simple. Okay. Okay, what you have to do? Okay, what you have to do? Okay. Now, how to find percentage change? Your situation is percentage change in kinetic energy is equal to delta K upon K1 into 100. Delta K, I can also write this delta K directly. K is always K2 minus K1. It is K2 minus K1. So how to find percentage change in kinetic energy? K2 minus K1 upon K1 into 100. K2 minus K1 upon K1 into 100. So is equal to this K2. What is K2? This is 2.25 K1 minus K1 upon K1 into 100 is equal to 2.25 K1 minus K1 means it is 1.25 K1 divided by K1 into 100. K1 cut, 1.25 into 100 means it is 125%. And as it is plus, your answer is plus, there is increase in kinetic energy by 125%. There is increase in kinetic energy by 125%. If your answer of K2 minus K1 is negative, if answer of K2 minus K1 is negative, you have to write K it decreases. You have to write K it decreases by 125%. Clear? Yes, formula remains always same. That is percentage change means final minus initial upon initial into 100. Simple. Okay. If your answer is positive, it increases. If your answer is negative, it decreases. Simple. So yes, it is one question which is based on such relations. Clear? Any doubt? Okay. We will see another question. See what is next question? Yes, what is next question? You are given a thin circular ring of mass m and radius r is rotating about its axis with constant angular speed omega. First case, you are given only one ring, okay, and that ring is rotating about this axis with angular speed omega. Clear? Hello? Okay. Now, 4 objects each of mass m are kept generally on the opposite ends of perpendicular diameter of rings. Now find what is angular speed. What is case 2? The same ring. Yes, the same ring, but on 2 diametrically opposite points. 2 diametrically opposite ends of 2 perpendicular diameters. So see, these are 2 perpendicular diameters. 4 objects. 4 objects like this. They are placed. Each having mass m. Then about the same axis. What is angular speed? What is angular speed? That is your question. Do you understand question? See, it is simple. Okay. First of all, you are given ring only, and it is rotating with angular speed omega. Now on this ring, 4 objects having mass m are placed generally. Then you have to find what is speed. Yes. Here we will apply law of conservation of angular momentum. Yes. Here we have to apply law of conservation of angular momentum. How? See, according to according to law of conservation of angular momentum. Okay, initial momentum is equal to final momentum. Simple. L1 is equal to L2. Now angular momentum, its equation is I into omega. Yes, here it is. L is equal to, it is I into omega. So here it is I1 omega is equal to I2 omega. Here angular speed is omega. Here it is omega 2, and we have to find omega 2. Now I1, that is moment of inertia. Here only ring is rotating. Simple. Here only ring is rotating. So what is moment of inertia of ring about this its own axis? Yes, it is m r square omega. Simple. Yes, it is simple. Okay, it is m r square omega because moment of inertia of ring about its own axis is m r square. Okay, yes, it is m r square omega is equal to, case 2, ring is rotating plus 4-point-like objects are also rotating. Yes or no? Yes. Ring is rotating plus 4-point-like objects, they are also rotating. And what is distance? If it is axis, then distance of this particle from axis is radius r. Of this particle, radius, because see, they are on opposite ends of perpendicular diameters. Okay, so yes, this each and every particle is a distance r from the axis. So how to write? See, here ring is rotating, so it is m r square plus 4 particles, so it is 4 small m r square omega. Simple. So what is difference in these two cases that you can easily understand? Yes or no? Yes. Now see, r square common, and r square common. So now I can write this equation as it is m omega is equal to, it is m plus 4m omega. Yes or no? Now you have to make omega 2 as subject, and if you make omega 2 as subject, it is m omega upon m plus 4m. So obviously your answer is this C, m omega upon m plus 4m. Simple. Yes, you have to make this omega 2 as subject. So see, length of question, see, length of solution. Okay, yes, I have to explain and you have to write in notebook. That's why 1, 2 and 3 statements we have to write. If you are solving such questions in exam, you have to write directly this step. So in step 1 and 2, it is your answer. Clear about this? So yes, it is how to solve some MCQs. Now next MCQ. See, next MCQ. Here it is. Okay, see, two bodies have moment of inertia I and 2I respectively. If their kinetic energies of rotation are equal, their angular momentum will be in ratio. In which ratio? 2:1, 1:2, 2:1, and I is to, that you have to find. So, two bodies have moment of inertia I and 2I. So yes, here I am writing I1 is equal to I and I2 is equal to, it is 2I. If the kinetic energies of rotations are equal, so A1 is equal to K. Then find the angular momentum ratio, means L1 upon L2 is equal to 1. So see, you are given 3 quantities, I, K and L. Moment of inertia, rotational kinetic energy and angular momentum. So first of all, you have to identify the relation between them. Here it is. Yes, we have already obtained such relation. Remember, we have such relation already. See, here it is K is equal to L square upon 2I. K is equal to L square upon 2I. So yes, we have to use this relation, such relation to solve this question. Okay, directly, okay. Here, K is equal to L square upon 2I. Now, as we have to find ratio of angular momentum, make L as subject. Then L square is equal to 2Ki. Then L is equal to under root 2Ki. Okay. Now, as you have to find ratio, then how to find? See, L1 upon L2 is equal to under root 2 K2 I2 upon under root 2 K1 I1. Okay, so yes, we can write this L1 upon L2, it is under root 2 K2. What is I2? I2, sorry, you have to find 1 upon 2, and so it is 1, 1. Here it is 2, here it is 2. So here it is 2 K1. Yes, what is I1? I1 is equal to, it is I divided by 2 K2, and I2 is equal to, it is 2I. Okay, 2 cut, 2 cut. K1 is equal to K2. So yes, K1, K2 cut. I cut. So it is 1 upon 2. So L1 upon L2 is equal to, it is 1 upon 2. So you can write this as L1 upon L2, it is 1 upon 3. Okay, so if you know this relation K is equal to L square upon 2I, you can easily solve this question. Yes, you can easily solve this question. Clear about this? Okay, so yes, it is how to find some, or it is how to solve some MCQs. If you know equations, if you know concept, if you know each and every law, then you can easily solve questions. Okay.